Hello, Assalamualaikum class, and good morning. I'm going to start the class now. Okay. Okay, let's start. Just to make sure you all can see my screen, correct? Okay, good. All right, let's start with the next chapter, the next topic, which is another method of parameter estimation, which is interval estimation. What method did we use in the last class for parameter estimation? What method did we use to estimate the parameter? Point estimate. That's good. So the first method was point estimate. So please remember this diagram again and all the symbols because it will affect your solution when you'd like to answer the questions given to you. Okay, in the last class we looked at point estimation. What is point estimation? Point estimation is when you estimate your population parameter using a point estimate, which is a single value. So that single value is used from your sample statistics because it is the best point estimate. So for example, you cannot, let's say you have observations, but maybe you don't have all the observations. So therefore you cannot calculate the average from the population. So therefore you would need to use your sample observations to calculate the mean. So here you would use X bar because that's the point estimate to get the mean by estimating your population parameter using your sample statistics um, uh, obtained from your sample, which is 39. Okay, so this is a point estimate, example of a point estimate for the population mean. Okay. Okay, so let's say this is your line number. So point estimate, what does it mean by point estimate? It's just a point on your line number. So it is a point, so therefore it is a point estimate. So this number is special because it is the statistics for that measurement. It's the sample statistics for that measurement. So this is a point estimate. Now, another method to estimate your parameter is what we call an interval estimation. So this is a point, this is an interval, okay? Another word that you use, um, another, somebody is coming in. Yep. Okay, another method, this method of point interval estimation is also known as confidence interval. Okay, so basically you know that this is a point, this is an interval. So what do we mean by an interval? So just now we have a point estimate, which is a point on the line number. So to estimate the population mean, would this be the only possible value that you can use to estimate your population mean? So it can be any other values, correct? So it can be maybe this value, that value, or any other values. So basically, it can be any value on the line that you can use to estimate your population mean. Doesn't have to be just x bar, But what's special if X bar, you know that it's a best point estimate. So the best bet that you know that what is the true value of population mean is X bar. But maybe it's not going to be exactly X bar. It could be any number. So how can you guess what the other numbers could be? So since this is the best point estimate, that means the best number, the other numbers should be should uh would be the number that would be around this figure. Okay, so our estimated of the population mean could be any number around this figure. It's no point having a number that's so far away from this figure, because you know that this is the best point. Okay, so um to do that, you need to somehow block this number through a boundary. Okay, so you might have an lower boundary and an upper boundary. So therefore, the other possible values would be around these boundaries only, which is this is an interval. Okay. However, that interval is going to be a special interval, because if we say that our parameter lies contains within the lower boundary and upper boundary, therefore, the probability that this is true should be of some probability. So here, if it's confidence interval, the probability is going to be 1 minus alpha. So probability means it's the likelihood. So therefore, 1 minus alpha should be high. For example, you've got 99%, 98%, 95%. So 1 minus alpha is high to reflect the confidence that you have that the parameter would lie between the boundaries of lower and upper limit. Okay. So what it means by this boundary, this probability is that if we collect many samples, from these samples, you would gauge that the parameter lie between these two values, lower boundary and upper boundary, is going to be 1 minus alpha. Okay. So our aim here, in order to construct this interval, is to get the value of the lower boundary and upper boundary. Because when we do that, then we will get a confidence interval. So for example, if you say that mu lies between a figure, for example, 3 and 5, and it equals to 0.99, this means that we are 99% confident that the population mean mu lies between this lower limit and upper limit. Okay, do you understand what is the difference between point and interval estimation? Okay, good. All right. So to summarize, point is 1 point, interval is a range of values lah, a range of values. But this range of values have to be special because you are confident that a percentage number, the likelihood, you have some measure of likelihood where what is that range of interval that the population mean might lie. Okay, so instead of you being cocky that only 1 point, so you have a range of values that you can tell what is the estimate of your population mean. Okay, so again, we're going to look at 3 types of measurements: the mean, the variance, and proportion. And in that, we're going to look at, for each measurement, we're going to look at when you have one population, the difference between two population, and similarly for other measurements as well. And I'd like to remind you again that this assumption that we have discussed in the lecture for point estimation still holds, okay? In which, if you want to calculate that confidence interval using the method that we're going to discuss, the observation has to be randomly taken. The sample has to be randomly taken. Observation has to be normal, and they need to be independent. Okay, let's look at the confidence interval for the population mean for apa benda ni? Population for confidence interval for the mean for one single population. Okay, yeah. Okay, so how to construct confidence interval for population mean? So you already know that the best point estimate for the population mean is X bar. Okay, so we mentioned just now that when we have X bar, so since X bar is the best point, therefore your confidence interval, your interval, other possible values must be around X bar. Okay, so since you know X bar has a normal distribution, we will see later why. So basically because of the sampling, so because it's X bar, so when you want to consider the sampling distribution of X bar itself is normal distributed. Okay, so therefore we have a symmetric distribution. When you have a symmetric distribution, so therefore our range of values would be around X bar. So this is going to be X bar plus minus some marginal error. Okay, marginal error, that means to the left is going to be the same distance as to the right. Okay, so therefore you have X bar minus the marginal error and X bar plus the marginal error. So this figure would be equivalent to X bar minus and X bar plus, where in which the marginal error is the same, have the same length. Yeah. So therefore we need to calculate this. So how do you calculate the marginal error in order to get the lower and upper limit? Okay. So the best point estimate for X bar or for the population mean is X bar. So therefore we can use the sampling distribution of X bar, which you have learned in chapter 2, where X bar has a distribution of normal with mean and a variance of sigma squared over n. In order to find the probability from this X bar, remember that you need to transform, right? So all normal distribution, if you want to calculate the probability, you need to transform it. So here you've got a transformation of a standard normal distribution, and therefore you have X bar minus mu over sigma over n here. So I'm not going to derive it, but you can actually use this to derive. So you can actually use this. You can actually use this statistic, this VEC, to derive and get your confidence interval as follows. Okay, so notice that, so this is your marginal error, yeah? So marginal error, you got that, you obtained that from, this is to simplify your calculation, this is just VEC times sigma over Zn, which is your marginal error. And where this is your lower confidence limit, the whole thing is your lower confidence limit, and this is your upper confidence limit, this is your marginal error. So notice that this is a two-sided confidence interval because you're looking at the left-hand side of X bar and the right-hand side of X bar. So this is your two-sided confidence interval. You can also get, for a two-sided confidence interval, your Z value here, which we will discuss later, is alpha over 2. We will see later why this is true for a two-sided confidence interval. You can also calculate a one-sided confidence interval, which I know you have the PDF for Montgomery book. You can look up for how to get the one-sided confidence interval. You can see that this is going to be Z alpha instead of Z alpha over 2. So what we're doing now, so the confidence interval reflects these, where this would be your Z alpha over 2 sigma over n, and this is going to be Z alpha over 2 sigma over n. So the length of value here would be equivalent to this. So there are many ways to write your confidence interval. So the one I showed you just now, this one is similar to this one, the middle part, yeah? So this is one way to write the confidence interval, where you can see this is the lower limit and the upper limit, okay? You can also write like this. If you have your textbook with you, it's being written like this, okay? But notice that when you want to write it in this form, this would have an equality sign for your less than 2 symbol, okay? Because you're reflecting the confidence interval. So you can write like this, the first one, the second one, or in this case, when it's population mean and you know that it's apa nama dia is so the formula you can also write like this, x bar plus minus, right? Because it's just the same. In when you want to calculate, you can just use this formula like that. So I'm going to use this formula for my next um, uh, calculation. So you can see here what you need to do is you just need to plug in the values of all the elements in this basic formula. Okay, and you can see there are 4 elements here. You've got x bar, sigma, and z alpha over 2. Okay, so what is uh what is what is x bar? I'm gonna ask same question all over again because people seem to forget. What is x bar? The sample mean, okay. Mm. Every, what is sigma? Okay, x bar is a sample, and what is sigma? Everybody please answer. Okay, population standard deviation, that's good. So this is sample mean, this is sigma. All right, so x bar is your sample mean, this is your population standard deviation, this is your sample size, and this is Z alpha over 2. You have already seen this in chapter 2 when you want to calculate the normal distribution. Okay, so because notice that when we construct this interval, you're using a normal distribution, a sampling distribution for x bar. So Z alpha over 2 reflect the value of probability of alpha over 2 from a standard normal distribution. So this is a value, not a probability. Okay, this is a value of Z. Yeah, this is a value of Z. So it means that um, so this is a Z value. So let's say you have uh this is your Z value with Z value has always have a 0 for the mean. Okay, so if so for a confidence interval, just now I said for a confidence interval this is 1 minus alpha, correct? So this area here is your 1 minus alpha. Okay, so I sheet this out. So if this is 1 minus alpha and Z normal distribution is symmetric, so this value here, this value, the area of probability is alpha over 2. Remember, this is the area. 1 minus alpha is the area of probability. Anything under the curve would be your area. Would be your area. anything under the area of area under the graph, area under your function would be the probability. So this is alpha over 2. The area, the size of the area is alpha over 2. This is also alpha over 2. Okay. So Z alpha over 2 is a value. So this is corresponding to that alpha over 2. This is going to be a Z alpha over, alamak, shoot, 2. Okay. So therefore, this one will be what? Minus Z alpha over 2. Okay, remember, this is a value, not a probability. The whole thing is now a number, so those are values. This is Z value corresponding to the area of probability of alpha over 2. Okay? This one? Z alpha over 2. Alpha over Z alpha alpha over 2. Okay? Okay? So you need to understand when you talk about confidence interval, you're talking about this area here, the area of probability. Yeah. So 1 minus alpha. So let's say this is 99%. So this is 99%. So this must be apa, 0.05, 0.05. If the confidence interval is 98%, that means this is 1%, the area is 1%, this is the area of 1%. Okay. So the standard rule is the area of probability, the area under the graph is your probability. Okay, I'll move on. So let's look at an example. A compressive strength of a concrete is normally distributed with a standard deviation of 2.18 times 10 to the 5 Pascal. A sample of 16 specimens has been randomly selected, which gives the sample mean of 2.499 times 10 to the 7 Pascal. Construct a 95% confidence interval on the mean compressive strength. Okay. So the first thing that you need to do is to understand the question. So here the question is asking for the 95% confidence interval for the mean. What is the symbol for the mean? The mean. With the mean in, yeah, so, hang on. Belum, ya, saya, belum lihat, ya. How do you write, so what is the symbol for the mean, for, so what is it exactly that you want to find here? So i.e. 95% confidence interval for the white. So what's the symbol to denote this 95% of the mean? The mean here denotes what? Confidence interval of the, here, the mean here, this mean denotes which mean? The population or the standard deviation? Sorry, the population ke or the sample mean? CI on the mean, the population mean, okay? Yes, that's right, the population mean. Sebab the whole idea of the confidence interval, the whole idea of the point estimate is you want to know your population parameter. So this is what you're interested in. So when you want to know the confidence interval, this is an assumption that you do not know the value of your population mean. Okay, so yes, so therefore that's right. So that means that this is so here you've got, so therefore the question at once confidence interval for mu. Okay, for the mean compressive strength, mu reflecting the population mean for the mean compressive strength. Okay, now uh, so the first thing that you need to do is understand what the question wants. In this case, it wants 95% for mu. The second thing is to extract the information. Extract the information. So here it says the compressive strength. Okay, here it says the compressive strength is normally distributed with standard deviation 2.189 Pascal. Standard deviation 2.189 Pascal. So you need to extract the information. So this one, does it refer to sigma squared or sigma? You know that it's a standard deviation. Okay. So which one is it? Sigma squared, sigma, s squared, or s? This one. It is sigma. Why is it not s? Because from the sentence, it doesn't say that it's taking this from the sample. It's just saying that, okay, a compressive strength is normal with standard deviation. It's not saying it's taken from a sample. But if you read the second question, the second statement, it says a sample of 16 specimen has been randomly selected, which gives. So it means that which gives the sample mean of 2.49. So in this case, the sample mean is cut is coming from the 16 specimens. So since you know the 16 specimens, let's say you have the observations for all of the 16 specimens, you can also find the sample standard deviation. But you're not going to use that because you already know the mother of the standard deviation. Mark standard deviation is, we already know. So we don't need to use the sample standard deviation. Okay? So that means that first what you need to do, first step is to find out what the question wants. The second step is to extract the information. And um like all student of mine, I would like you to draw this so that it be easy for you to visualize. Easy for you to visualize where all your extracted information is coming from. So here you've got sigma here, it's got x bar here, and here. So those are the information that you will obtain from this passage. Okay, right. So how do you do this? How do you do this? Just use the basic formula. The basic formula I use is x bar plus minus alpha over 2 sigma over n. So and how do you get alpha? So because 95% is 1 minus alpha, 1 minus alpha is 0.95, so alpha is 0.05, therefore alpha over 2 is 0.025. Okay, in order for you to use the formula for confidence interval for the population mean in particular, I want you to remember this mantra. Okay, is sigma known? If it's sigma known, then you would need to use the basic formula. You need to use this formula because you can plug in the value of sigma into this formula. Okay, and then just stop there, and this would be your diagram for the 0.95, 0.95, and therefore the value for z alpha over 2, which you will get from the table in table 4. Table 4 gives you the value, and last time you have used it, gives you the value of z, and you will get a value of 1.96, and the rest follows that you just plug in the values that you have here, and you would get this interval. Okay, so my question is to you, so this is your answer for the 95% mean is almost known. Okay. Moment, Ali, um, I will get to later. Sigma, no, sigma is not always known because actually it's very difficult to get sigma. So sigma is not always known. So in practice, difficult to get sigma. So therefore, sigma is not always known. So we will get to another formula later, but we will modify it using this formula. Okay, right. Now, my question I'm posing to you now is that so now from the passage, we know that the 95% confidence interval is between 2.489 and 2.5. So, is it possible that the mean compressive strength for the true mean what true mean compressive strength uh, is 2.5 times 10 to the 7? Okay. Okay, good. Yes, with 5% chance. So it's true because why? Because why is it yes? Why is it true? Why is it true? Why why is it true? It is possible. So why is it true now? Anyone? Yes. Um, that explains Antonius. Your explanation is correct. Has only the 5% possibility in the imaginative. So basically, because 2.5 is in that interval, right? This value of 2.5 is definitely contained in this interval with that population with this 5% chance or ataupun 95% probability to lay in that margin calculated because this value is within this interval. So you know that 2.5. So you got 2.489. So that means that let me just write it here. This 95% is the possibility that so if this is 2.489. Oh god. Okay, let me check whether I can use my Wacom. Alamak. Boleh ya? Cuk, cuk. 2.489. This is 2.5. 1. So 2.5 is here. Okay. So that means this is 2.489. So that means this is 2.5 is within the interval that you have calculated, which this interval has a 95% possibility that it will lie in that calculated interval. Okay, okay, right. Okay, right. So tadi the Antonio's question, somebody's question, Muhammad Ali asked that if it if it all the time do we know the value of sigma or the population standard deviation. So it is not possible for us to, if not all the time we will know the value of sigma. So therefore we need to adjust this formula. Okay, but for unknown population sigma, you have further conditions. Okay, so what are the conditions? So this is the formula that you used just now, where you have a known population variance. Okay, let's say you do not know the population variance, but your sample size is large. So therefore, to compensate for the unknown, you can use the best point estimate for sigma, which is S, right? So this is the best value to estimate your sigma. So you place that with S, and because n is large, therefore you still can use the distribution for the interval. However, if you do not know the value of the population variance, you replace your sigma or sigma squared with S. Okay, so replace sigma with S, but because n is small, you can no longer use a vec distribution. Okay, so to cater for that vec distribution, to cater for the small sample size, you need to use a t distribution. Okay, so you don't really have to remember all these formula. It's sufficient for you to remember the basic formula and adjust the formula according to your condition, to your situation. Okay, so just remember this formula, and for example, if you do not know your sigma, just replace it with S, and then if is and check whether your sample size is large or small. If it's large, you use Z, otherwise you use a T distribution. Why do you use Z and T? Because you know that a Z distribution, if you remember, oh shoot, yeah. Remember the difference between Z distribution, this is a Z distribution. If this is your Z, your T, this is 0. A T distribution would have the same shape, but it's smaller. So this is a T distribution. Okay. So if it's mana ni? If it's large, if you got large sample size, you use a Z. If it's a small, then you use a T distribution. Just mind that for a T distribution, you need to get its degrees of freedom. So in this case, it's n minus 1. So how do you remember all these? If you look into your statistics table on page 2, or I've put up the final formula for this course on your e-learning in the resources section on top of your e-learning. I've put up tables and formula. Okay, so this, if you look in your table, this is actually the marginal error. The Z times sigma over n is the marginal error for this one, and this is for, and that is the, you can find the marginal error of this confidence interval from here, and also for a t distribution you can also use the marginal error here. Okay, so that is so that you can construct your confidence interval easily just looking at the formula sheet if you don't remember. But anyway, it's most likely that your test 1, test 2 is going to be online. I'm not sure about finals. So you just need to understand, I guess, because you're going to do an online assessment, at least for the first two, test 1 and test 2. Okay. Okay. Right, let's look at an example. A research engineer for a tire manufacturer is investigating tire life for a new rubber compound. Okay, for a new rubber compound, and has built 16 tires and tested them to end of life in a road test. The sample mean and standard deviation are given as follows. Find the 95% confidence interval on the mean tire life. So again, when you're talking about 95% confidence interval, you're talking about the population mean. Okay, for mu, and then extract the information. So obviously it says the sample mean for that 16 tires, yes? So therefore it's going to be that, right? So these are all the information from this passage, X bar and S, okay, because they're all from the sample of the 16 observations, right? Okay, so how do you do this? Now, just now, our mantra is, do we know our population mean? So this is your basic formula. Is sigma known? If sigma known, so straight away you will use this formula, regardless of the sample size, okay? But in this case, sigma is not known. Therefore, you need to use an S from the sample, the standard deviation from the sample, and then check, since you do not unknown population variance, so therefore you need to check whether your sample size is large or small. In this case, it's 16, so therefore it is small, and thus you need to use this formula here. That means you replace sigma with S, and then replace that with a t distribution with a degree freedom of n minus 1. So for this distribution, so everything else you can just plug in the figures. So this is x bar, this is your S, this is your N. So for this one, again, it is 0.95 in the middle because it's a confidence interval that you would like to have. And you need to look at T15 distribution. So that will be on your table number 6. Sorry, table number 5. Table number 5. So you will get that value. Please have a look at that and solve this to get the answer to be as follows. Okay, that would be your homework. Okay, to calculate this. Okay, we're going to look at another example, but this time it's a similar example to one example two, but I'm going to change the sample size to 50. Okay, so the information is going to be the same, but now except for the 50 here. So is sigma known? Not known. Use S, and since n is large, therefore use exact distribution. Okay, so that is the formula that you use, and you need to calculate your confidence interval for the mean. Okay, do you have any question? It's easy, kan? It's easy, isn't it? From so extract info. Extract info. Extract info. Know your question. Get question. Extract info. Extract info. Use formula. Use formula. Verify if required. Then plug in values. That's it. But the uh, the issue that students have is actually the extracting of the information. Because if you're extracting it wrong, then you will get a different answer. So, for example, um, let's say, let's say in the first example just now, first example, First example ke? So in the first example, to find. In the first example, let's say you extract the information wrongly. Let's say you assume that sigma that is given here is from a sample. So you would write S coming from here, and therefore you're going to use a t distribution. So that would make your whole answer to be wrong. Okay, so extracting information is very important. That's why I always stress you need to know the symbol, because your formula is dependent on your symbol. If you use that strategy of finding your that strategy of constructing your confidence interval. The method that I've shown here is um, is crucial, that you know which information that they have given, which symbol to use in order for you to construct that interval. Okay. So, okay, that's it really. Um, so I'm going to leave you. So that's it for today's lesson. Do you have any question? I'd like you to go back and do exercise for exercise 1 and 2, and let me open up your tutorial. The tutorial question, I've also put it there. Put it on your e-learning. Let me see. Okay, yep. Tutorial question. Question assignment, exams, exercise. Okay, yeah. Okay. This is an example taken from here. This means with test 2, semester 1. So these are examples of the tutorial question. I hope you can see it from your screen. So first example, yeah. So this is quite straightforward, question 1A. But here is asking for a 98% confidence interval for the population mean. 98%. So you might have to just now all my examples are based on 95%. So now here is 98%. Okay. Um, so from the question, you know which parameter that you're being asked. Okay, here it clearly shows population mean. Okay. What about this one? Okay, let me see, like this one. For 2B, construct computer for the variance, for the field volume variance. So the measurement here is variance. So that means this is sigma squared. So 90% confidence interval for the sigma squared. We haven't done this yet. We'll go through. So the confidence interval to construct the confidence interval for variance is not similar. It's different from the mean. Okay. So this is still one population, because there's only one population in this question. This is construct 99% for the true proportion of defective chips. So true proportion of defective chips. So this should be a pi. 99% for pi. Yeah, because it's proportion. Okay. All right. So do exercise. Do exercise from the slides. Exercise 1 and 2, and um, also the tutorial questions. Okay, and there are many more questions that you can do on the Montgomery book as well. So there are many you can also do the quizzes that you can find on the internet as well. Okay. All right. Do you have any questions so far? I hope you understand now what's the difference between a point estimation and interval estimation. We have just only done the population mean. So we're going for t distribution. Can we just use the table? No. For the t distribution, yes, you may use the table. But since we're online now, you can explore how to get the values from the values. You can actually get it from, so all the values for the distribution, for z distribution, t distribution, chi-square distribution, all those distribution can also be obtained from your Excel. Try Excel. You can use, so you can use your table, table to get the values for distribution, for t distribution, etc. Ability and t. You can also use Excel. Okay. So practice on both. Right. Any other questions? 9:28. Oh, half an hour je. Okay. Great. That's good. Mm-mm. Okay. Half an hour pula daripada pukul 8 eh. 8:30. About 1 hour juga. Okay. All right. If there's nothing more, tak ada semua faham ya? Semua faham ke? Senyap je. Okay. There's 57 in here, but I only get apa benda ni response from what less than 10 people in here. Okay, good. Alright, okay. Let's kalau dah kita akan tengok our attendance. Where's my attendance? Attendance window. Tak ada lah pula.